Hi, and welcome to Failurology, a podcast about engineering failures. I'm your host, Nicole.
And I'm Brian, and we're both Calgary, Alberta, Canada.
Thank you again to our Patreon subscribers.
For less than the cost of a grand chai tea latte, 3 pump skim milk, light water, no foam, extra hot caffeine water, you can hear us talk about even more interesting engineering failures.
Is that what you order, Brian?
That is 100% not what I order. I don't even understand what half those words are. I'm not sure what light water is. Skim milk, I think I know what skim milk is. I usually go for the Americano. It was the first thing I ever ordered at Starbucks, I think when I was in grade 8 or 9. So the first thing on the menu, I figured America knew what they were doing with coffee. I wasn't sure what all the other names meant, and I've just stuck with that. I figure you can't go wrong with espresso and hot water. Like, that's, if you can't make that well, probably shouldn't have a coffee shop.
Yeah, I also drink usually black coffee. Also, chai tea latte, is it coffee or tea? I don't know. Do you know?
I'm not sure. I do like chai tea, because again, I wasn't sure what all the different kinds of tea were. I started drinking chai tea 20 years ago, 25 years ago, and I just stuck with that.
Oh.
The odd time I'll venture into orange pekoe tea if there's nothing else, or Earl Grey, but chai tea latte, or chai tea, I guess, way to go.
Fair enough.
And now you've all learned way more about Nicole and I. Things you never even knew you wanted to learn.
Yeah, our hot beverage choices.
Hot coffee, black. No cream, no sugar, no milk.
Same.
Don't make this complicated. Don't make this complicated.
Right?
Should we move on to the...
Yeah, I think so. I think they've heard enough.
This week in Interesting Things in Engineering, the Houston Astrodome. So this isn't really news. The Houston Astrodome isn't a new thing by any means. It isn't even called the Astrodome anymore. In fact, it's actually pretty old news, but it's something that we thought was really, really interesting, and so we wanted to share it with you. The Houston Astrodome, it was one of the first major sports venues to install artificial turf, or what's now known as AstroTurf. So the Astrodome is in Houston, as the name implies, and the dome opened in 1965 with Tifway 419 Bermuda grass, which was bred for indoor use as a playing surface. So for all you grass people, I'm sure that means something. It doesn't really mean a lot to me. So for the rest of us, I was like, it's grass.
Yeah, this is grass.
We all know what grass looks like. I mean, I know golf courses have different kinds of grass, and there's a Kentucky bluegrass that does something, or it's in a lot of places, but I'm running out of things I know about grass. The dome ceiling of the Astrodome had several semi-transparent lucite panels that allowed sunlight to feed the grass, which grass needs sunlight and water to grow.
Photosynthesis for the win.
Yeah, we all learned about that in grade 10, grade 9 biology back in the day. But soon the players, they were complaining about the glare from the lucite panels. So to combat this, 2 sections of the panels were painted white, but then the grass died from lack of sunlight. So they needed to come up with some sort of solution for this, because having grass on a baseball diamond, that's kind of important to have. So for the 1965 season, the Astros played on green painted dirt and dead grass.
Green.
Not ideal.
Sorry, green painted dirt. That's really funny. I laughed really hard when I saw that.
You gotta make do sometimes.
But how long would it stay green for? Wouldn't it get dusty and then become brown? Like, do you have to paint it for every game? So many questions.
I'm not sure. It's like I assume that they have some sort of budget for painting the dirt, so it looks green. The Oakland A's, they did play when they were they still are in the Oakland Coliseum. They would play part of the season where there would be a football field on top of some of their playing field.
Yeah, same thing in San Francisco before the 49ers and Giants moved to separate stadiums. I've been to the previous stadium, I forget what it's called right now, but they used to play in a shared space as well, which was weird.
Was it Candlestick Park before it was Levi Stadium? Yes, Candlestick Park, yes. Yes.
And so they eventually installed a new type of artificial grass, which at the time they were calling chem grass. But over time, and thanks to the Astrodome, it's now known as AstroTurf. So if you ever wondered how fake grass got the name AstroTurf, it's literally because it was installed at the Astrodome first, which is really cool and something I didn't know.
It sounds very futuristic, right? You're playing on space grass.
Yeah, and this is the 60s. So, this is the mid 60s, and I believe it was 1969 that man landed on the moon. So this is definitely a very space-time. And Houston has one of the space centers. There's Houston and then in Florida. And so, I think the Astrodome and AstroTurf actually suits Houston very well. But at the time, it was a new product, so they could only get a very small amount. So they started with the infield and foul territory at the start of the 1966 season at a cost of $2 per foot.
Which actually sounds like a good price, like $2 a square foot. Like there's real estate in Vancouver that's way more expensive per square foot than that.
Well, this was also 1966.
Still seems like a good deal.
Yeah. And then the rest of the field was completed by mid-July. So about, what would that be, 4 months into the season? Maybe halfway through the baseball season. Baseball seasons are very, very long. This, I think, is also really cool. The groundskeeper is dressed as astronauts to clean the turf with vacuum cleaners between the innings, which I think would be really, really cool to see if you're just sitting at a baseball game and you see these people come out in astronaut, costumes, and they're vacuum cleaning the grass. That'd be really interesting. So the original AstroTurf product was a short pile synthetic turf, and it transitioned to a more tall pile polyethylene turf with infill since the early 2000s. So I believe that tall pile would be more like what you and I are used to seeing as grass. Pile length being the length of the turf that stands up. So short pile is like a thin carpet, and tall pile is more like a shag carpet or grass, except it's obviously stands straight up.
Yeah, and with AstroTurf, and as AstroTurf evolved as a product, and into artificial turf that we have now for football and baseball. Now there's rubber pellets that are kind of embedded in the grass just to soften up people landing on the turf surface or just running on the turf surface, so it's less damaging to ligaments. Because this was one of the problems with early sports stadiums that use AstroTurf. It was essentially put down almost right over top of the concrete, so it was a very hard surface. But now it's been engineered to be a more forgiving surface, and softer on things. So it's still a really neat product that they came up with, essentially fake grass.
Yeah, I've actually played indoor soccer I wouldn't say they're stadiums because there's no seats, but in indoor soccer fields that have those rubber pellets in them, and it is quite a difference from running on just straight AstroTurf on concrete. It is a lot more cushioning. You do get the rubber pellets a little bit of everywhere, so that's not as fun, but I'll take what I can get. The Astrodome I thought was pretty cool. There's also some other interesting grass stadiums going on in the States. So Allegiant Stadium has rolling grass that rolls out into the parking lot. And then there's turf underneath. So the university likes to play on turf, but the professional league likes to play on the AstroTurf. So they kind of have both, which is pretty cool. And then the University of Phoenix also has rolling grass that rolls out into the parking lot, just so that they can feed the grass, get it sunlight, water it appropriately, and then they roll it back in for a game.
Yeah, which I think is really neat because you get the weather benefits, I guess, of a dome stadium, or certainly with a dome stadium, you're not subject to rain and storms and wind, but you can also play on a natural grass surface. So it's really neat that the grass just rolls out into the sunlight in the parking lot and then rolls back in when they need to play a game on it.
Yeah, I think that's really cool. So if you want to read more about the origins of AstroTurf, check out the sources on the webpage for this episode at failurology.ca. This week's episode of Failurology is brought to you by Long's Long Pants.
They're long pants made by Longs.
Not to be confused with shorts. These are different.
This seems pretty self-explanatory from the name.
But yet, here we are, explaining long pants.
Long's Long Pants. Now, on to this week's engineering failure. United Airlines Flight 232.
Another plain one.
Another plain one. They're some of my favorite ones to do. And I hope they're also your favorite ones to listen to. But if they're not, you could just skip this week's episode.
You're really selling me on the plain ones. Before you joined and I was trying to do plain ones by myself, they're really intimidating because it's like learning a whole new language. But I've really come around to appreciate these ones for what they are. And I think this one specifically is very, very interesting.
Yeah, when I first started on failurology, it took me quite a bit of time to convince Nicole that we should do the De Havilland Comet episode. We had to record it a few times, and now we've done a few plane ones, so I'm really excited about doing hopefully more plane ones in the future.
Definitely.
All right, so United Flight 232, it occurred on July 19th of 1989, and this was a flight that was supposed to go from Denver to Chicago and then continue on to Philadelphia. And unfortunately, it did not make it to Chicago. It came up a little bit short. They landed, I'm going to call it unceremoniously, in Sioux City, Iowa, after a catastrophic failure of the tail-mounted engine due to an unnoticed manufacturing defect in the engine fan disc, which led to a loss of all three hydraulic systems on the aircraft, which should not happen. That's, you lost the main system, you lost the backup system, and you lost the backup to the backup system. That is not ever a good thing to happen.
And what happens when you lose the hydraulic systems? Like what purpose do they serve?
The hydraulic system on aircraft, I mean, it's somewhat similar to your car. So the hydraulic system will provide things like braking. It'll provide control surface actuation.
It's pretty significant. So it controls your ability to speed up or slow down, as well as your elevation and your direction, your steering, pretty much all of the things you would do to make the plane go a certain way, you can't do anymore.
Yes, so all the control surfaces, especially on larger aircraft of this vintage, they're all hydraulically actuated. So you'll move the control column in the cockpit, and then through the hydraulic system, there'll be a corresponding change in a control surface. So the ailerons will move for roll, or the elevators will move up and down for pitch, or there'll be movement of the rudder for left, right, and yaw in there. Either way, losing one hydraulic control system, not the worst. There's some systems that are down a little bit. There's backups to that. Losing a backup, not good. Certainly very reduced control surface, movement or braking ability. But losing all three, the plane is essentially not really good at doing the flying piece of flying.
It's important. It's an important part of the
it's
exercise.
Pretty important, especially when that's what it's supposed to do. If you're not on the ground and you're supposed to be flying and you're not, that's not a good spot to be in. So for anyone that's listening that doesn't know what the DC-10 is, it's largely been retired now, certainly in North American passenger service. There are freight companies that still operate the DC-10. I believe that FedEx and UPS have a few that are still in operation, but they're slowly being phased out. So the DC-10, it's a 3-engine aircraft. So there's one engine underneath each wing like we're used to seeing, but then there's also an engine in the tail of the airplane. So this is a 3-engine aircraft, and United had operated them since 1971. By the time of the crash, the plane had operated for 43,400 hours and just under 17,000 cycles. So it's completed 17,000 or just under 17,000 landings and takeoffs, and it's got a lot of time on the air. From like 43,000 hours is a lot of time.
So if an engine was lost, like what happened here, or a hydraulic pump failed, there is the ram air turbine, which can provide emergency electric power to the auxiliary pumps. And we're going to get into this shortly, but that doesn't matter because all the hydraulic systems were severed, and so the auxiliary pump has nothing to pump. But I do think the ram air turbine is an interesting system. The Gimli glider that we covered in one of our mini failure episodes on our Patreon also had a ram air turbine that was used to power some of its controls when it ran out of gas. But as it started to slow down, the ram air turbine didn't have enough airflow to keep everything operational, which I thought was a really interesting story. So for the engine and hydraulic system to offer this redundancy, if 2 hydraulic systems were rendered inoperable, the one remaining system could allow for full operation and control of the plane. So they are piped in such a way that if 2 of them are down, they have 1 remaining. So you kind of have 3, you have your regular system, your backup, and your backup, as Brian mentioned.
Yeah, there's basically 3 independent hydraulic systems for this aircraft. Again, redundancy is a big thing in aviation. It's important to have redundancy because if something fails for whatever reason, you can't pull over to the side of the road and call AMA or AAA, depending on what country you're in. You need to keep that airplane flying. You need to get that airplane back on the ground. And having a redundant system is a good thing to have.
Yes.
So at least one hydraulic system has to be functional to control the airplane. As we mentioned, the control surfaces are hydraulically actuated. There's braking that needs to happen. So it was not designed to revert to manual control if the entire hydraulic system failed.
It sounds like they thought that the chances of all three hydraulic systems failing simultaneously was impossible, and it sounds like they didn't plan for it, which does seem like a huge oversight to me. But at the time, this hadn't happened before, and so they had thought, well, we have three redundant systems, so we're protected. And spoiler alert, they were not.
Yeah, and so the hydraulic systems on the DC-10, they run in completely different areas in the aircraft, so that way if something did happen, one of the hydraulic lines ruptured, it wouldn't rupture any lines beside it because the other set of hydraulic lines is in a completely different set of the airplane. And the tail, where this failure occurs, I believe that's the only spot on the DC-10 where all three hydraulic lines did run parallel to each other. So not only did they lose all three hydraulic systems, which is bad, but this is really the only spot in the whole aircraft where something like a fan blade separation could sever all three hydraulic lines.
Yeah, so everything, Murphy's Law, everything that could go wrong did go wrong.
But as we'll find out, there's a lot of things that did go right with this incident.
Yes, true. A lot of things kind of fell into place
that allowed them to get the aircraft on the ground with survivability. So on this flight, like all flights, you have a flight crew that will wind up dealing with this situation. So the captain of the flight is Aldred Clare Haynes, or Al Haynes. He's 57. He's been hired by United Airlines in 1956. He's got almost 30,000 hours of flight time, with over 7,000 hours in a DC-10. So he's phenomenally experienced. He's got tens of thousands of hours flying the DC-10. His co-pilot, or first officer, is William Roy, or Bill Records. 48, he's been hired by United Airlines in 1985. He's got 20,000 hours total flight time with 665 hours in a DC-10. Not quite as experienced as Al Haynes, but certainly very, very experienced. And their flight engineer, the guy that rides in the back of the cockpit sideways, is Dudley Joseph Dvorak. He's 51. Been hired by United Airlines in 1986. He's got 15,000 hours total flying time with 1,900 as a flight engineer and 33 hours in a DC-10. So again, this is a very, very experienced flight crew that's sitting up front. They're in the neighborhood of 75,000 total hours of flying time cumulatively. So this is a phenomenally experienced flight crew to deal with the situation.
I think we talked about this on the de Havilland episode, but can you refresh my memory on the role of a flight engineer? Because I don't think we have those anymore. Can you tell us what they did and then kind of when they were phased out-ish?
Yeah, so the flight engineer is basically a big systems manager. So he'd manage things like moving fuel between different fuel tanks and setting different engine settings and monitoring the engine stuff. So the flight engineer, like Nicole said, we don't have those on modern commercial aircraft. A lot of their role has just been taken over by automation and computer systems. So the flight engineer, he would sit behind the flight crew. So the captain usually sits on the left. The first officer will sit on the right, and then the flight engineer will sit sideways just behind them. So back then, when we didn't have as much automation on commercial aircraft, he was a really essential crew member to keep everything flowing, monitor systems, make slight changes to systems, and kind of optimize the flight. So in this incident, there's a fourth member of this crew that will become incredibly important in allowing United 232 to make it into Sioux City, Iowa. So
he really saves the day. Honestly, I think this would have gone much worse without him.
Oh, this would have gone phenomenally worse without a fellow by the name of Denny Fitch, who's initially riding in the back of the aircraft, and then he comes forward. He's a training check airman with United, so he's just deadheading. I can't remember if he was deadheading home or just deadheading to where he was supposed to be working for the next day. But he comes forward. He lets the flight attendants know that he has experience as a DC-10 sim instructor and as a training check airman. And as we'll find out, he is going to actually kneel between the captain's seat and the first officer's seat and do a lot of manipulation of the throttle. So as part of Denny Fitch's training and kind of sim experience, he's learned about the 1985 crash of Japan Airlines Flight 123 that crashed after total loss of the hydraulic systems. And interestingly, he's practiced kind of the conditions that Japan Airlines Flight 123 experienced in the simulator, just as part of training and just trying to figure out what went wrong or how to possibly deal with this situation if it ever comes up in the future, just in the sim, so that he's never tested this in a real life scenario.
I don't think anyone would want to willingly do that.
No, which is one of the reasons that we do a lot of work with simulators, is because you can simulate all of these crazy conditions in the sim, and nobody winds up dying, which is great. So it's a great learning tool. Pretty much every airline, I'm going to say every airline, uses simulator training as a part of their training program.
I do want to add too, I think we're going to talk about it a little bit later, but I believe several people have tried to recreate United 232 in the simulator and never had results like we saw in real life, which is interesting.
Yeah, this is one that doesn't go very well in a simulator, as we'll see. There's a lot of things that are happening very quickly in this, and a lot of things that even people with combined 75,000 hours of flying time just haven't seen before. And then also, although they're not part of the cockpit flight crew, there's 8 flight attendants that are on this flight, and the 8 flight attendants and kind of the cabin crew on this are very critical in passenger safety and survivability of this flight.
Yeah, I think the fact too that there's 8 flight attendants tells you just how big this plane is. So there's 296 people on board, passengers and crew. I typically don't see more than 3 or 4 flight attendants on a flight. So this plane is likely double the size of the planes that I would fly on in, domestic flights in North America. So definitely a really, 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 really big plane, lots of people on it, lots of, I guess, risk there.
Yeah, so the DC-10, it's a wide body aircraft, so it's got 2 aisles on the DC-10, and this is used for transatlantic flights and trans-Pacific flights, and so it's not a tiny aircraft by any stretch of the imagination.
So United 232 took off from Denver at 1:09 p.m. local time or mountain time, and it was headed for a stop in Chicago on its way to Philly. At 2:16 p.m. mountain, so a little after an hour, the DC-10 was at flight level 370, also known as 37,000 feet, or 11,000 meters altitude for all you metric lovers out there like me. At this point, the tail engine completely explodes catastrophically and just disintegrated. When it did that, it took with it parts of the number 2 hydraulic system. And if that had been the only hydraulic system it took with it, this flight would have gone a lot more smoothly.
We probably wouldn't even be talking about it.
Probably not. But when it did that, it also severed the number 1 and 3 hydraulic system lines, which serve the horizontal stabilizer on the tail section. So in the span of seconds, this entire engine disintegrates. It takes all 3 hydraulic systems with it. And yeah, not good. Very, very bad. So the plane felt a jolt, the autopilot disengaged, and the first officer took hold of the control column while the captain tried to wrangle the tail engine. But all the instruments were indicating malfunction. So, you're in an airplane. You can't really see what's going on. So I don't even know. I assume it took them a few seconds, if not a few minutes, to even figure out that they'd lost the tail engine because, they can't see it.
No, you'd figure out pretty quick that you'd lost an engine. I've shut down a couple engines in flight for various reasons. When you lose an engine, you notice right away. There would be very loud bang on this that you would likely be able to hear. Engine instruments you would see an immediate loss of power in something like this where the fan blade separates. It would be very obvious that you lost an engine.
Okay, good to know. Good thing I'm not qualified to fly a plane. I'm more of a passenger. So the flight engineer recommended they cut off fuel to the tail engine, which I think was a really good idea. And this all took place over 14 seconds. So this did not take very long. So with all 3 of the hydraulic systems compromised, the plane, of course, wasn't responding to any controls, and it started banking to the right with the nose dropping, which was the same position that it was in when the engine exploded. So, Brian, correct me if I'm wrong, but my understanding is when they lost all the hydraulic controls, they basically locked all of those controls in the position that they were in at that time, and then they're kind of stuck there.
Yeah, exactly. That's what would happen. So whatever position the controls were in, which was a slight bang to the right, when they lost all the hydraulic systems, that was really the position that the controls were set in. So I'm trying to think if there's a similar example of, driving your car, like if you lose a tie rod or something like that, where, if you try to move the steering wheel, left or right, it doesn't really respond to anything.
I was actually going to say in HVAC controls, we consider that fail in place. And so if we lose an actuator for a damper or for a valve, some of them are set to just failed in that position. And then some of them are set to fail open or closed. And so they would automatically, when power is lost, they automatically revert back to a specific position. But then, yeah, there are some that fail in place. So this would be pretty similar. So by reducing the left wing to an idle and then max power to the right engine, they were able to level out the plane, which was really smart. So they still had the ability to control the output of each of the engines. So that did give them a little bit of steering, but it wouldn't be much.
Yeah, there's not really anything that they have here for control authority. So their entire ability to move the airplane left or right is dependent on power settings on the left engine and the right engine that are on the wing. So it's kind of similar in the same way if you've ever driven a skid steer or something that has, tracks where, you can, if you want to go to the left, you make the right track go much faster, or you bring the left track back, and it, so that's all they really have for any sort of turning or directional ability. Not great.
No. So they did try to activate the ram air turbine, but they didn't have much success. They radioed the United maintenance personnel who were in San Francisco, but they were told that since the loss of all hydraulics was, quote, virtually impossible, they didn't have a procedure.
Which is not what you want to hear when you call up maintenance people.
No.
These are people on the ground. Back then they had computers and they have manuals, and they're really smart people that have, in theory, figured out all of these, procedures. And when you hear that they don't have a solution to your problem, that's not good. Because remember, we're still up at, 37,000 feet or 35,000 feet. So you're still a ways up there. You're not anywhere close to the ground, and you need to get on the ground. And the guys in San Francisco don't have a solution. That's not ideal.
Yeah, I would be one unhappy camper. So you're in the air, you've just lost an engine, you've lost all of your controls, and the ground personnel says, "Oh, we didn't plan for this, but good luck." No, give me something. Again, this is the 80s. This is a different time, but even though you think a scenario is extremely unlikely or quote unquote impossible, you have to plan for it so that you have to do a full risk assessment. To me, that's part of engineering is figuring out everything that can go wrong and planning for it. And, you don't always have the budget for that, but at least you've thought it through and you've kind of made some analytical decisions on which risks you do have to allow for. But to me, that's a big part of engineering is figuring out what your risks are and how you can overcome them.
This was also a time where they didn't quite have the same level of computer technology and simulation technology that we have now for doing, analysis work that would be commonplace in engineering. Still not what you want to hear when you call the people that are supposed to have solutions.
That's true. They probably have all the manuals in paper copy, not like today where you would just control F and find certain keywords to figure out in the manual.
Yeah, and aviation has certainly progressed considerably in the last 20 years. 20 years ago, everyone was dragging around paper charts for, approaches and manuals, and, everything was paper and binders. And now it's essentially an iPad, glass cockpit stuff. And, so it's replaced a lot of the steam gauges. So yeah, back then they would have had all these manuals in the cockpit, or, certainly on the ground, they would have had to go through for these procedures. And there's not really anything in there. So they're stuck with dealing with this situation because that's what they have to do. So with this loss of control that they go into what's known as a phugoid cycle. So what happens in a phugoid is the aircraft will pitch up and climb, and then it will start to pitch down and descend, and it slows down and speeds up as it does. So this is not by any means a fun situation to be in. So pitches up, the airplane climbs, then it starts to slow down, and then it descends, speeds up as it goes down. So not fun. So with every one of these phugoid cycles, United Flight 232 loses about 1,500 feet of elevation, or for metric people, 460 meters of elevation. So they're slowly, over time, descending, and they can't do anything about this. They're eventually, they're losing altitude, not quickly, but this is going to become a concern. So Denny Fitch, recognizing this, like I mentioned, he lets the flight attendants know that, he's got DC-10 experience, he's deadheading, and so he goes up front. Flight attendant lets him up in the cockpit, introduces himself to Al Haynes, kind of runs through stuff, says he's ready to assist, and so Denny Fitch kneels in front of the throttle quadrant, so between the two seats, the way that this aircraft is laid out, captain on the left, and then in the middle, kind of where your gear shift would be in a car, that's where the throttle quadrant and a whole bunch of other stuff engine related is located, and then where the passenger seat in the car would be, that's where the first officer sits. So by manipulating the throttles, Denny Fitch is able to reduce his fugoid cycle and make some really, really rough steering adjustments.
I got to imagine that steering a plane, especially in this scenario, is like trying to steer a boat.
Yeah, I think it would be similar to if you were driving down the highway and you had a fast food tray and you stuck it out your window. That's kind of at the level that they're at for trying to make this thing go left and right. Like, they don't have a lot to work with in this. But he is able to get some level of control. It's not great, but they have a chance. So as they're assessing this whole situation and they're slowly descending, they're in contact with air traffic control and the maintenance base in San Francisco, as well as the operations group in Chicago. So air traffic control, they've basically cleared them for whatever they want to do. Planes are moving out of the way. They get cleared for an emergency landing at the Sioux Gateway Airport in Sioux City, Iowa, which is about halfway between Denver and Chicago. But now they got a decision to make, or at least discuss. So they feel that they can make Sioux City, Iowa. It's not the longest runway in the world. It's not the shortest one either. It's paved, which is good. But they got to decide, do you make a belly landing so they keep the gear up, or do you try to put the landing gear down? And the reason that this is an issue, or something they need to discuss, is first of all, the hydraulic system is compromised, and landing gear mechanism isn't operative. It was hydraulically assisted for how the gear comes down. They do have a way in the cockpit to basically manually drop the gear, but also they've been able to maintain some level of control, and putting the gear down will change the aerodynamic profile of the aircraft. So this is a big decision. If you throw down the gear and the airplane becomes uncontrollable, they don't have a way to bring the gear back up. So once they make this decision and commit to this decision of putting the gear down, they're stuck with having the gear down the entire rest of the flight. As I'm sure you can imagine, the gear creates a lot of drag with the aircraft, so it won't fly as well. They won't be able to glide the aircraft as far as what they could with the gear up. It's kind of the same thing if you're in a boat and then you put your hand in the water, it makes a boat not go as fast.
But I assume that the landing, if you just think about the landing specifically, the likelihood of success is improved with the landing gear down, right? That's why the risk was to an extent worth taking.
Yes, as long as they can get the aircraft to the runway. So in a scenario where if they were short and they wound up putting it down in, say, in a field or in a lake, the landing gear, as it hits the ground or hits the water, it will likely cause the aircraft to spin or cartwheel. So once they put the landing gear down, they have to make it to the runway.
That's a big risk to take on.
Yeah.
I mean, there's lots of other problems, but that's a big risk.
Yeah. So with this, obviously they're going to Sioux City, Iowa. The fire trucks and the crash trucks have been notified for their arrival. So they plan to land on runway 31. So the way runways are numbered, they're based off the magnetic heading. So this would be a magnetic heading of 310 degrees, and then they just drop off the zero. So if you've ever wondered how runways are named or numbered, that's how the numbering system works. But they decide they have very limited ability to control the airplane, so they decide that runway 22 would be a much better option. So instead of landing basically northwest or on a heading kind of running northwest, they decide that they're going to land on runway 22, which is kind of a southwesterly runway. Fortunately, the fire trucks, they were all waiting on runway 22. They were kind of using that as staging area. So very quickly, they have to move all these fire trucks off the runway, because if the airplane hit the fire trucks, that's bad on multiple fronts.
You don't say.
Yes. So the other thing too, with losing the hydraulic system, they weren't able to put the flaps or the slats out on the aircraft, which is so the flaps in the aircraft, they come from the rear part of the wing. And the increased lift and the increased drag, we use them on takeoff and landing, and then as well as the slats on the wings. So those come out of the front part of the wing, and it just, with the angle of attack on the aircraft, it just allows better airflow for landing with these aircraft. Actually, before we talk about landing, I do want to mention a couple of other factors with United 232 that led to them being able to even have this aircraft landing on a runway with this. So when they take off out of Denver, it's just afternoon, so they're operating in the day. So that's huge. They're able to, first of all, identify where Sioux City, Iowa is. They're able to visually identify the runway. Where if they had done this at night, if you've ever driven at night or flown at night, it's really hard to figure out where things are. You just have, essentially street lights to guide you for where you need to be. So having this happen in the day was a contributing factor to the survivability of this crash. Secondly, it was in what's known as visual meteorological conditions, or VFR type weather. So they're not in clouds, they're not in snow, they're not in rain. They can see where they need to go. So again, that ties into the day component. If they had to do this sort of operation in cloudy weather and very inclement weather, basically land with the use of instruments, it probably wouldn't have worked out as well as what it did. The other contributing factor, one of the other contributing factors, is the Air National Guard, or the National Guard, had been conducting operations this day, so they had a whole bunch of personnel that were available. They'd also practiced this scenario. I believe it was an aircraft crash scenario, so they were very up on emergency procedures for dealing with an aircraft that was crashing in Sioux City, Iowa. The other thing that really helps them out later on for the survivability is that this was right at shift change at the hospitals, so they were able to have some of the nursing staff and the medical staff, kind of extend their shift, and then they were also able to have the shift that was supposed to, come in that afternoon to arrive early. So they were double staffed in the hospital for this aircraft that had 200 plus people arriving in Sioux City, Iowa. So there's a lot of factors that contributed to the success of the survivability on this. You can call it luck, coincidence, but all of these things, the 4 or 5 things I mentioned, do contribute significantly to the survivability of this crash.
So a safe landing of an aircraft requires a speed of 260 kilometers per hour, or 140 knots, and a sink rate, or an elevation reduction rate of 1.3 meters per second, or 300 feet per minute. But they were going much faster and sinking much faster than that. So Flight 232 was going about 410 kilometers per hour, or 220 knots. So almost twice as fast, not quite twice as fast. And a sink rate of 9.4 meters per second, or 1,850 feet per minute, which is about 6 times the sink rate that they would ideally have to land this aircraft safely. And the aircraft ended up landing about 3 p.m. Mountain Time, just about 2 hours after takeoff. As they were coming in to land, the plane started to roll, and Fitch was not able to get it under control. The right wing touched down first, spilling fuel that ignited immediately. The tail section broke off on impact. The plane bounced several times, shredding the landing gear and breaking the fuselage into several large pieces.
At this point, even getting the aircraft on the ground in a controllable-ish manner on the runway is a phenomenal piece of aviating. When this first happened, if we go back to them talking to San Francisco's response was basically like, good luck. This easily could have been catastrophic and had nobody survived this incident. So the fact that the flight crew was able to get this aircraft on the runway is phenomenal.
The right wing was torn off the plane, and it skidded sideways, rolling over on its back, and it came to a stop in a cornfield to the right of runway 22. The majority of the passengers and crew with fatal and serious injuries were located in first class and the rear section, which was impacted by smoke from the fuel tank fires, which is interesting because I had thought since first class sat where they did that they would be in one of the safest spots, but Brian told me I'm wrong, and first class is actually not one of the safest spots, which I did not know, which is interesting.
Yeah, so overall, airplane crashes, airplanes are built for survivability.
Miraculously, everyone in the cockpit survived despite some serious injuries. And most of the 184 survivors, so 184 survivors out of 296, all things considered, I think is actually really, really good. this could have gone much worse. Most of those survivors were in the middle section with only minor, and some people have had no injuries. I mean, at least they were recorded as no injuries, so relatively speaking. And again, this is physical injuries. I'm sure they were never the same after this. I wouldn't be surprised if a lot of these people that survived never got on an airplane again. I probably wouldn't either. Not that I think, airplanes are... I mean, the likelihood of being injured or dying in an aircraft is significantly low. It's less than driving a car. But after you experience something like this, I just don't think I'd get back on a plane. Unfortunately, United Airlines had a Children's Day promotion on this day, and so there were 52 children on board, most of them traveling alone. So they were amongst the victims and survivors of this crash.
So after the aircraft comes to rest, the National Transportation Safety Board obviously gets involved with this. They want to figure out why this happened, just to make sure that it's not going to happen in other DC-10 aircraft or other aircraft, or if there needs to be an engineering change or a design change. The NTSB always looks at incidents that involve aircraft crashes, certainly ones where there's fatalities. So the NTSB determines a couple causes of the accident. So they say there's inadequate consideration given to human factors, and there's also limitations in the inspection and quality of control procedures used by United Airlines engine overhaul facility.
And I think that first point, inadequate consideration given to human factors, is not related to the humans on board the aircraft. It's related to humans in the design, manufacturing, and maintenance departments that have dealt with this plane.
Yeah, and just on the human factors thing, I wasn't going to bring it up since this is, more of an engineering podcast, but when this incident occurred, the flight crew and certainly the captain was essentially seen as the sole authority. You wouldn't ever question the captain. He was the only person that made decisions for this. And United Airlines was one of the first airlines in the, certainly in North America, that embraced the concept of, then it was cockpit resource management. Now it's crew resource management. And Al Haynes does a really good job of listening to all the people that are involved in this. So having Danny Fitch sit between the two seats, listening to the flight attendants, involving the flight attendants, in the bracing procedure, and having people involved and contributing to the decision-making process, and then taking their inputs and making a decision from that. So it's a really key component in the survivability of this that I feel sometimes gets overlooked when we just look at the engineering side of this failure. So the engine that failed, it had a titanium alloy stage 1 fan disc, which had a previously undetected metallurgical defect in a critical area, which then caused a fatigue crack, which ultimately led to the catastrophic failure of the fan blade that went through the engine, caused the failure of this engine. So the investigation found penetrating fluorescent dye on the crack, indicating that they were checking for cracks, but unfortunately they still missed this crack. It's because titanium reacts with air when melted. Impurities can form and cause cracks. So General Electric, which was the manufacturer of this engine, they used a double vacuum process to reduce this risk, but impurities still formed. They later added a third vacuum stage, which minimized this considerably. So the engines that were used on the DC-10, Dash 10 that was involved in this incident were General Electric CF6 engines, and it was one of the first high bypass turbofan engines. So a large number of fan discs were examined by ultrasound, and at least 2 other engines were found to have similar defects. So this is a really good thing that they found these defects when the aircraft were on the ground, instead of having another catastrophic failure that would possibly lead to a similar scenario here. The failure was uncontrolled and knocked out hydraulic system for the DC-10, or at least a significant portion of it. So this is a scenario that doesn't appear anyone had really planned for. And, I can see why. I mean, this is a scenario that had a very high unlikelihood of happening. Losing all 3 hydraulic systems, especially from being severed by a separated fan blade. And this included the plane's design team. They hadn't really considered it. Manufacturer hadn't considered it. And there was no procedure in place for, a complete loss of flight control. It was just something that people didn't feel could happen. However, despite all of this, the crew, they were able to use throttles to maintain some semblance of control. But unfortunately, they were coming in a little hot. The plane broke apart and it caught fire upon landing. By no means, it's a perfect landing. I mean, parts of the airplane didn't stay together on landing, but this could have been so much worse.
Yeah, definitely. So as Brian mentioned, there were a few factors that contributed to the higher than really expected survival rate for those on board. So the accident occurred during daylight and in good weather. It occurred during a shift change at the Sioux City Regional Trauma Center and Burn Unit, which allowed much more medical personnel to be on staff. And it also occurred when the Iowa National Guard was on duty at the Sioux Gateway Airport. So there were 285 trained personnel to assist with triage and evacuation. That's some pretty significant coincidences.
When this does occur at the time of year, the Midwest does see significant pop-up storms. So they could have, it's not unreasonable to expect a giant line of thunderstorms over Iowa at this time of the year. So they got really lucky that it was good weather. There weren't giant cumulonimbus clouds and thunderstorms occurring over the Midwest right now.
But the fact that it occurred during shift change at the hospital and while the National Guard was on site at the airport is, I think, those are fantastic coincidences that really, saved a lot of people's lives and really helped this situation go much better than it could have or probably would have otherwise. So as we also mentioned, reconstructions of this accident on flight simulators have been attempted, but even expert pilots are unable to produce a survivable landing on the simulator, which, again, not really surprising. This is a pretty bad scenario. And I think we also saw similar flight sim results from people trying to recreate the Gimli glider accident where they ran out of fuel and had to belly land. So I'm not super surprised. I got some questions about flight simulators, though. Do they always plan for the worst case scenario? Would you have factors that would allow you to have positive outcomes, or do they on purpose make things as worse as possible?
So typically if you go to simulator or sim, they throw the worst case scenarios at you. Because again, you're trying to train for situations that you hope never occur in the cockpit when you're flying, but it's not uncommon where on takeoff, you'll lose an engine, and then there'll be an engine fire, and then you'll lose hydraulic systems. So again, it's a good training environment because if things go wrong, you just reset the sim and you can run through the scenario again. So through sim, you're trying to get to a point where responding to emergency scenarios and situations is just part of the muscle memory. So if something does happen when you're flying, you lose an engine or there's an engine fire, instead of panicking in that situation or looking it up in a manual, you can go through the initial steps to isolate and deal with that problem right away because you've done it so many times in the simulator. I mean, it's the same thing with first aid training. If anyone does recurrent first aid training, you do the CPR exercises so many times, or opening up an airway that you hope you never have to use that in real life, but since hopefully you've done it so many times in a first aid course, it's just ingrained into your muscle memory, where if you see that situation happening, you don't have to go look it up on the internet. You know the first couple steps that you need to take to mitigate and deal with that situation. So there you have it, the catastrophic failure of a fan blade on the tail engine of a DC-10 on the way from Denver to Chicago. Through the actions of the flight crew, they were able to bring the DC-10 to Sioux City, Iowa, and make a semi-controlled landing on the runway that led to the survival of 184 people, in a situation that many people on the ground considered impossible to survive due to the lack of controllability of the aircraft.
For photos, sources, and an episode summary from this week's episode, head to failurology.ca. If you're enjoying what you're hearing, please rate, review, and subscribe to Failurology so more people can find us. If you want to chat with us, our Twitter handle is @Failurology. You can email us at thefailurologypodcast@gmail.com. You can connect with us on LinkedIn, or you can message us on our Patreon page. Check out the show notes for links to all of these. Thanks everyone for listening, and tune into the next episode where we'll tell you about the Harbor K condo collapse, a structure so problematic that it collapsed before it was even complete. Bye everyone. Talk soon.